Matthews, who's also from maths. So, go.
The seeds in the head of a sunflower spiral out from the middle in such a way that the number of seeds in the head of a sunflower is what's called a Fibonacci number. So I'm going to tell you a little bit about Fibonacci numbers. So about 8 centuries ago, an Italian mathematician called Fibonacci devised this sequence. So we fix our first two terms, 0 and 1, here in gold. To make the third term, we just add the first two terms together. So 0 plus 1, we get 1. To make the fourth term, we add the second term to the third term. So we get 1 plus 1, and we get 2. And we can keep on doing this and growing this sequence. Each number in this sequence is called a Fibonacci number. If we take the ratio of consecutive Fibonacci numbers, so for example, if we do 13 divided by 8, that's 1.625, and do this for larger and larger Fibonacci numbers, that ratio, 1 divided by the other, gets closer and closer to this number in the middle. This number, 1 plus root 5 over 2, is called the golden ratio. So if we jump forward a mere 800 years, a mathematician called Fibonacci defined our second sequence down here, which is similar. So again, we fix the first two terms to be 0 and 1, which is shown in blue this time. But now, we're still going to combine two numbers to get a third, but this time, the way we combine them is going to be decided by the flip of a coin, okay? If I get heads, I add these two numbers together. If I get tails, I take away the first number from the second, okay? So here's an example sequence. We do heads, heads, tails, heads, heads, tails. So to make the third number, I got heads, so I add 0 and 1 to get 1. I then get heads again. So to make the fourth guy, the fourth term, I add the second and third, 1 plus 1, and I get 2. Now I get tails, I flipped to get tails, and so I take the third number, the third term from the fourth. So I do 2 take away 1, and I get 1 again as a fourth term. And so by continuing to flip the coin, I can go along this sequence. If I got heads every time, I'd get my original Fibonacci sequence. So the question is, can we get something like this golden ratio, 1 plus root 5 over 2, from this sequence? And the answer, bizarrely and weirdly, is yes. And Fibonacci showed that we can get a random golden ratio for this sequence, and it's about 1.1. But it's only known approximately, whereas the golden ratio is known exactly. The idea of my PhD is to find out this random golden ratio, 1.1, exactly. Thank you very much.